All right, good morning, good day, or good afternoon, good evening. All right, it's morning here. So today we're looking at integration by parts. Should we use the DI method or should we use the by parts? I think in your exam it doesn't matter which one you use, but uh, it's your choice. So I'm going to do like three examples for us to see which one is preferable, which one is shorter, which one is more understanding, but you should, whatever you're going to use, you should know how to differentiate and integrate. That's very important. So the first one we're going to do is we're going to integrate x squared sine x dx. We're also going to integrate e to the power of x sine x dx. And we're also going to integrate x to the power of minus 3 by 2 ln x dx. All these are past paper questions. So I think this will summarize uh, what you need to do or how to do it. Alright, so I'm going to take the first one, which is integral of x squared sine x dx. Okay, I'm going to use by parts first. So by parts, for you to use by parts, you need to know this rule. You need to know this rule. Very important. So I is inverse streak. This is like sine inverse of x or tan inverse. This one is logs, which is ln. This one is algebra, like x squared. This one is trig, like sine x or cos x or tan x. This one is e to the power of x. So this is your choice for choosing u. So in this case, my u is going to be x squared. Oh, so we should write the formula first so that we know what we're trying to integrate. So just write the formula. So this is integral of u dx equals to u minus integral of v dx. Okay, so my u is x squared, my dv dx is sine x. Okay, that's good. We're getting somewhere. Now, because I need to use this formula, so I need to find du dx, which is 2x. Then I need to find v. I need to find v from here. By finding v, I need to integrate. Now, if I integrate sine x, get minus cos x. Because if you differentiate cos, you get minus sine. Minus times minus will be plus. So yes. So I just put it in the formula. So the formula will be so uv so x squared, that will be minus times in this, right? So times in this, so minus x squared cos x minus integral of v in cos x, so minus cos x, just for the mind, that will be plus, times du dx, 2x. So I'll just simplify. So minus x squared cos x plus integral of 2x cos x. Okay, you can see we have another by parts again. So I'll just use a different color. So I need to integrate this using by parts again. So I need to integrate this using by parts. So what I normally do, I will do this somewhere and bring it back. So this is what I normally do. So I want to integrate 2x cos x dx using the formula I already know. Your u should be 2x, your dv dx will be cos x. So du dx will be 2, then v, again, whenever you integrate something, differentiate and see if you get that back. Now if I integrate this against sin x, because if I differentiate sine, I get cos. I use the formula that will give me uv to multiply this. So 2x sin x minus integral of, so what's the formula again? Integral of v dx. So v is to sin x times 2. So this should be 2 here. So this will give me 2x sin x minus, now if I integrate 2 sin x, 2 is a constant, this will give me times minus cos x. So that gives me 2x sin x minus, plus 2 cos x. So this is what I get. So I'll take this, I'll take that, and I'll bring it here. So remember, I have solved this. So I'll get x squared, I'll get minus, I'll get minus x squared cos x plus 2x sin x with 2 cos x plus c. So this is my answer. Again, if you're confused, just watch the video again. The formula is direct, but I feel this is a very long method where you have repeated, but there are some you have you need to use I. So if you've done some integration, you need to use I. Alright, now let's check if we are correct using the DI method. So the DI method is just differentiation and integration. So this is DI method now. So this is differentiation, this is integration. So this is x squared, this is sine x. So if I differentiate, this is 2x, this is 2, this is 0. If I integrate, this is minus cos x. If I integrate, this is minus sine x. Always check. If you differentiate sine x, you get cos x, so this is minus. If you differentiate cos x, you get minus sine. Minus times minus is plus. Now you see I don't need what is here. I will explain why. Now, the first thing, this is always plus, minus, plus the alternative. Plus, minus. I will multiply diagonally. But for the last one, I will multiply like this. There's a reason why. So there are rules for using DI. You know the rules. Any integration by part is done. The first rule is if you can integrate, I'll just type that 1 second. So the first rule is if you can integrate into the figure, I need it to be bigger. I'll just write, no problem. I'll just write down. So first rule is if a row can be integrated when multiplied, stop. This is the first rule. The second and most important one, if a row is multiplied and is repeated, stop. I will do examples for both. So for this question we're using number one. If I integrate the row, if I multiply the row and I can easily integrate it, then I should stop. You see, x squared and sine x, I cannot easily integrate, so I cannot do that. Quite have to use by part. 2x cos x, I cannot. Here I can, because this is just integration of minus sine x. So this will be, so I multiply, this will be, so I multiply diagonally, so minus x squared cos x, done. Then multiply, that will be plus 2x sine x, 2x sine x. Then remember this, I'm using the minus from minus 2x, and that's why it is plus. Then plus integral of 2 sine minus, so this is minus 2 sine x dx. So that's the first rule. If you can integrate a row when you multiply them, so this will be minus x squared cos 2x plus 2x sine x. The minus 2 will come out, so minus 2. And when you integrate sine x, you get minus cos x plus c. If you differentiate cos x, you get minus sine. So this, the final answer will be minus squared cos 2x plus 2x sine x plus 2x plus 2 cos x plus c. So this is my final answer. Now let's check if it's the same thing like what we got before. So let's compare. Remember, we're comparing these two values. Compare this and this. So x squared cos 2x. Okay. Where did I get 2x from? Wow. How nice. So this is x squared cos x. So move 2 there. What did I write to? So move 2 there. Move 2 there. So that's just x. Then 2x sine x plus 2 cos x done. So you see, this is just like you're iterating something. Actually, this is how your calculator or your decimals or your anything you use to integrate, this is how they do it. See, just programming. So they are iterating the formula, but it does it in milliseconds. Now, this is one. Now let's see another way we can use step two. So let's say I want to integrate. Let's say I want to integrate. Okay, I think I got one ready. So I want to integrate e to the power of I want to integrate. So this is number two, question two now. E to the power of x sine x dx. Just remember the two rules we said earlier. So I'm using the di method. For you to use by parts, we'll use by parts. Let's see. So let's use di first. Di, this will be e to the power of x sine x. Now, the question is, which one do I take to be d or I? Anyone you can integrate easily, take it to be differentiation. Anyone you feel you can integrate easily. So normally if you have algebra, make it d, because you can easily. So you are actually using I8, but anyone you feel you can integrate easily, take it as d. So if you're already good in differentiation, take it. If I differentiate this e to the power of x, see, remember this is plus minus. So e to the power of x remaining to the power of x. If I integrate this, I get minus cos x. Is it minus cos x? Yeah. If I integrate this, I get minus sin x plus. You see, it keeps repeating. Now, if you watch this very well, so remember our rule? I'll use red. This is danger now, danger mode. If you look at this, if I integrate it, if I multiply them, and I bring out a minus from the integration sign, I will get the original. This is what the second rule is saying. So you can see e to the power of x sin x. The minus is a constant, so you can bring it out. So this is what the second rule is saying. So I will just give you an idea of what we're doing now. So this is minus. This is minus e to the power of x. I'm multiplying cos x diagonally plus e to the power of x sin x. Then the rule says I. So this will be minus e to the power of x sin x. If you're very familiar with integration, you will know that this is something you will do when you're using by part. So sine x. So what we normally do if something repeats is we call this I equals to minus e to the power of x cos x plus e to the power of x sine x minus I. Because I'll bring the minus outside, I will be that. So this will be 2i equals to same thing. I don't want to write it. So I will be minus e to the power of x cos x plus e to the power of x sine x over 2 plus c. Easy. So you can see, if you use by parts, you will still get to this I stage. You can see BI method is easy and nobody will penalize you for using it. Okay? It's easy. The main thing they want to see is, they want to see this step. So it's just integration by parts. but in a different form. So you have to integrate over and over again. So that's why they will always check your marking scheme to see how they award the marks. If they don't allow DIB, I don't believe any examination body. They will just use by parts, and they will give you the uh, steps of what they need to see for you. All right, so I believe so you can give yourself any. You can go to Desmos, you can go to even use ChatGPT to give yourself a question, try to solve it and check if it's correct. You can do as many practice questions as you can. All right, choose